Okay, for the part B of the same question, that is question number 33's part B. This is question number 33, part B, and we have to evaluate the definite integral for the given function. And let's consider this function as I. So I can write it as 0 to pi by 2. Now sin 2x, I can write it as 2 sin x into cos x tan inverse of sin x into dx. And now we are ready to make the substitution. So let's make the substitution. Let's sin x is equal to t. So differentiation of sin x, this is if I differentiate this with respect to t. So we are not going to differentiate with respect to x, but we are going to differentiate this with respect to t. And we are going to get the new limits as well. So differentiation of sin x is cos x, and differentiation of x is dx by dt. Differentiation of t is 1. So this is now cos x into dx is equal to d. This is the differentiation, and let's get the new limits. So when x is equal to 0, so if I put x is equal to 0, t is equal to 0, and when I put x is equal to pi by 2, t is equal to sine of pi by 2. So sine 90 is 1. So this is new limits are 0 to 1. Okay, let's make the substitution here. So now our integral in terms of t will be integration. This is, we have the new limit 0 to 1. So this is 0 to 1, and 2 is constant. So let's take it out. And sine x is t. So this is t. Now cos x into dx is dt. So let's replace that with dt. Now our differential element is dt, and this is tan inverse into t. So this is tan inverse t. Okay, so this is our function now, and I can write this function as, so I'm going to use the integration by parts here. So if I use the acronym ILATE, so I will have to treat this tan inverse 1 as the first function and this as the second function. So I'm going to write that in order. So this is 0 to 1, 2. This is tan inverse t into dt. And let's use the integration by parts, which says that the integration is the first function into integration of second minus integration of differentiation of first function, which is tan inverse t, into integration of second function. The whole has to be integrated. Okay. And this has to be for the limit 0 to 1. So first function differentiation of second, differentiation of first into the integration of second, the whole has to be integrated. This is dt again. Let's try to simplify this. 2 is out. This is now tan inverse t. Integration of t is t squared by t, and differentiation of tan inverse t is 1 plus 2 square into integration of t is t squared by 2, and this whole has to be integrated once again. So dt with the limit 0 to 1. Okay, now I is equal to 2. This is tan inverse t into t squared by 2 minus, let's take 1 by 2 out. So this is t squared 1 plus t squared into dt for the limit 0 to 1. And to integrate this, I'm going to add plus and subtract plus 1 here. So I is equal to 2. This is tan inverse t into 2 squared t minus half. And I can write it as t squared plus 1 upon 1 plus t squared minus 1 upon 1 plus t squared into dt for the limit 0 to 1. So I is equal to 2. This is tan inverse p into p squared by 2 minus half. Integration of this gets reduced to 1 minus this is 1 upon 1 plus t square into 2dt for the limit 0 to 1. Okay, so this is t square. Now finally I is equal to 2 tan inverse p into t square by 2 minus half, and integration of 1 is t, and integration of 1 plus t square is once again tan inverse t for the limit 0 to 1. Okay, so let's open up the bracket in the internal one. So this is tan inverse t into t square by t minus half t plus half tan inverse t 0 to 1. Let's multiply all these with 2. So this becomes tan inverse t. So this is tan inverse t into t square minus t plus, this is now tan inverse t, and let's evaluate it for the limits 0 and 1. So for all these terms, we are going to put t as 1. So this is tan inverse 1 into 1 square minus 1 plus tan inverse 1 minus, this is tan inverse 0 into 0 minus 0 plus tan inverse 0. That should give us the final answer. So tan inverse 1 is 5 by 4, 1 square is 1, so 5 by 4, negative 1, tan inverse 1 is 5 by 4, negative tan inverse 0 into 0 is 0, minus 0, and tan inverse 0 is, okay, so this is 0, tan inverse 0 is 0. Okay, so this is tan inverse 1 into t square minus t plus tan inverse t. So tan inverse 0 is 0, and finally we are left with I is equal to 2 times 4 minus 1. So this is 2, and finally it's pi by 2 minus 1. So pi by 2 minus 1 is the value that we have evaluated this function for. Thank you for watching.